Hi everyone, welcome to join ASUS and AMD Driving the Data, the Future of Data Center webinars. My name is Irene Chen. I'm in charge of the ASUS server and workstation marketing. It's my pleasure to have you to join this webinar with us today. And before this webinar starts, please be aware this webinar will be recorded and you can approach your local ASUS representatives for the presentation deck or video after the webinars. In today's agendas, first, we will have ASUS server and workstation BU head Robert for the warm opening for us. After that, Alexei from AMD will give us an overall look of AMD's new EPYC 7003 processors. Our Western Europe BD Director, Daniele, will then share with us ASUS perspective on the AMD EPYC server and solutions. If you have any question during the presentation, you can type in your question by using the WebEx Q&A function on the right bottom side. And we have our sales and our RD and PM stand by with me here to answer your questions. After the presentation, there will be a Q&A section to answer the most asked questions. So now, let's have Robert for our openings.
Hi everyone, welcome to ASUS AMD EPYC 7003 launch webinar. This is Robert Chen, Head of Server BU of ASUS Tech. I'm very happy to share with you our partnership and our commitment on AMD platform. ASUS Server BU, we have 25 years of experience. We believe our core competence count on these three: performance, green computing, and software management. From performance point of view, ASUS, with our patent and our technology and experience, we have already achieved 712 worldwide benchmark #1 on Spectre.org. This remarkable numbers is also the worldwide #1 among all the server companies. Green computing, we have our thermal radar 2.0 and a power balance technology. We can help customers to save more money with better TCO. And software remote management tools. We have our ASUS in-house ASUS Control Center, ACC, which can manage the whole data center from server storage all the way down to the client devices like notebook, like PC. And in the last couple of years, we have already sold more than 1.2 million licenses of ACC globally. And with EPYC 7003, we also introduced new 8-speed 2600 chip with better performance and better security. So that is our three core competence. And as you know, in last couple of years, the server industry has big paradigm shift. For example, from cloud computing back to 2008. Right now, ASUS, we also engage with our cloud service provider customer for level 11 business. And for AI, as you know, AI, no matter for inference, for training, for deep learning, for machine learning, and at ASUS, we have hundreds of AI software engineers. In the last couple of years, we have successfully delivered the AI software solution for Taiwan's National Supercomputer Center with AI and data analytics. For 5G, also, ASUS Group, we are one of the member of Open RAN, and also we have product for CU and the DU. And the edge computing, we also join Open Edge with Open Edge product, and also ASUS, we have AIoT business unit. So that is our product for this to meet this new change. Our long-term partnership with AMD from EPYC platform point of view, back to 2016, ASUS is one of the alpha partner for AMD EPYC 7001. And we work together with AMD to introduce different platform, different product. And on EPYC 7002, as you know, EPYC 7002 has more high code count and PCIe length, and also PCIe Gen 4, and also more DIMM slot. Also, this applies to EPYC 7003. So ASUS will work together from 7001 all the way to 7003. And for example, last year, ASUS will introduce this ESC 4008 E10 product. This is a 2U, 4 GPU, 1 socket platform. And with the overall ranking of the performance and the overall result is 9.2, very good. So for the new EPYC 7003, ASUS, we have prepared 8 different new products for you on AMD platform and more SKU. And for the previous generation, EPYC 7002, with the BIOS upgrade, we can easily upgrade the previous generation to the new EPYC 7003 generation. So this is our product portfolio and our commitment on AMD platform. And I'm very happy to join this webinar, and I hope you enjoy this event, and our expert will share with you all the product portfolio and the detail later. Thank you.
Okay, thank you for Robert for the opening. We got some feedback like they cannot hear the sounds from Robert. In that case, later on we will share the webinar presentation deck and also the video to you guys if you need it. So please ask your local ASUS representative for the video and also the presentation deck. Okay, next we will have welcome Alexei from AMD. He will talk about the new EPYC 7003 processor with us. Welcome, Alexei.
Thank you, Irene. Let me share my deck. Let me know if you can see it. So, okay, thank you. So let's start. My name is Alexei Nichuyatov. I'm responsible for technical marketing for server platforms here in Europe, actually in EMEA, and it's an honor for me to be here today to join ASUS Tech in effort to bring you the latest and greatest. I am to introduce the 3rd generation EPYC processes and walk you through some of the details. So let's roll. You know, whenever I'm talking about our roadmap, it's the same story all over again. Our roadmap is not really changing, and that's a testament to our really efficiency. We are delivering on our major milestones. It's now the 3rd generation processor codenamed Milan. But if we're looking at the core microarchitecture, it's called Zen. And so we have been already through 3 iterations, including the latest one. They're all fitting in the same socket infrastructure. AMD is always trying to make sure that, you know, we have a stable platform policy. It doesn't mean that, you know, customers would upgrade their service, but it does mean that you can start deploying your service based on the previous generation ROM processes and just continue buying very similar platforms already with Milan inside. And so if we're looking at our strategy in terms of production, you know, 1st generation EPYC processes, codenamed Naples, was introduced back in 2017. We validated our approach. It was a pure system on a chip approach. The 2nd generation has happened in August 2019. And what we've done, we moved to a chiplet-based architecture, doubling the number of cores, introducing PCI Express Gen 4. And actually, while there was some compatibility, if you wanted to actually start using PCI Express 4 or DDR 3200, you were to buy a new platform. Now, it's an easier uplift between Zen 2 and Zen 3 because mechanically and thermally the boards are staying pretty much the same. And so, yeah, it's very exciting because our roadmap cadence is very tight, and we are working a lot with ISVs around the globe. And sometimes we just saw that they just don't have enough time, to be on time with us to launch, because it's just been so little time since August 2019 when we launched Rome. And so Zen is an evolutionary Zen 3 is an evolutionary microarchitecture, but it still delivers substantial performance gains. We're using pretty much the same chiplets across a few product lines, but we configure them differently. And so if we are to look at strategically at what Milan third generation processors are about, it's a new Zen 3 core microarchitecture delivering up to 19% better IPC. We've substantially upgraded our boost frequencies, so it's 300 to 400 megahertz high. So it's both how much work you do per thread, per clock, and it's also, we are able to pump up, the frequency for the applications that are single or low threaded. So it's really a balanced processor that really covers pretty much virtually 100% of workloads. Our fabric that is providing this secret sauce to connect all these chiplets, up to 64 chiplets together, is also clocked at a higher speed. So it's working synchronously with a memory clock, and I'll talk about it in a second. There are new security features. We're making the platform more flexible, so people can now use also 6 DIMM memory channel interleave setting in BIOS. And again, last but not least, it's drop-in compatible for many platforms. And so this is all about chiplets. So we can put on a substrate up to 8 chiplets. And not only that, it's like a Lego block. We can disable or enable cores inside each and every chiplet. And so depending on how you configure that, you can actually offer to the market application-specific processes. And we actually map workloads in terms of what's good, better, best for specific SKUs. The other thing is it's still pretty much the same chip. So the same 8 memory channels at DDR3200, the same PCI Express 4.0, 128 lanes per socket. And it's actually the same if you put 2 CPUs together, because half of the links are used to connect to each other. We've upgraded security, we've upgraded performance, so we'll talk about it. At the microarchitectural level, we've really widened our execution units. We made sure we can load faster and prefetch data faster. There is a better bandwidth internally. So that's an amazing feat, because if you think about it, it's the same socket, it's the same thermal power, ranging from 155 to 280. And even if it's 280 watts, still the performance you provide per watt is amazing. So our strategy as a company is really to move customers from 4-socket to 2-socket, and from 2-socket to single socket, because we have so many cores. They are high performance, each core, and we have a lot of IO bandwidth, a lot of memory bandwidth. So it's really allowing you to proliferate your data center space and cram in more compute power if you need to. So synchronous clock speeds, obviously, this is a very important point for the applications that are latency sensitive or memory subsystem sensitive. What we're able to do now is actually probably reduce our latency up to 5%, because before we would have our fabric, for example, with 64 core process, our fabric would be clocked at 1466 megahertz, while the DDR double data rate was running at 1600. So it was asynchronous and it wasn't as efficient. And so now it's working in a lockstep. Next, so you see that when we look at our architecture, we don't have any external chipset at all, and that has to be accounted for when you are talking about thermal power in general, because it's not a head-to-head comparison. You need to account that the entire chipset is already under the hood. So this central IOD, input-output device, essentially our chipset. It has all memory controllers, unified memory channel controllers. It has, the entire I/O there. And then we connect cores through the Infinity Fabric interface, those individual chiplets, up to 8 of them. Last but not least, there are 8 memory channels, and what you could do if you need to, if your application is NUMA-aware, you can slice and dice cores and memory channels into quadrants, into domains, and so you can get better performance, 2 to 5% better performance. But if your application is not aware of the NUMA domain architecture on AMD, then you just use it as one SMP socket. And so it's really a great flexibility that we actually introduced with our second generation 7002 processors, codename Rome, and it's still there. So really a very flexible approach, especially for the ISVs, to take their time to optimize for our architecture. And you can actually do different kind of NUMA domains from one. So when one socket is looking like all cores are going to be in one domain, to 2 or to 4 separate domains, each equipped with own memory channels. And so, yeah, large cache is a big thing with the third generation. It's one of the largest differentiators versus the second generation. So what we've essentially done before with Zen 2, with Rome, you would have on each chiplet 2 core domains, each equipped with its own shared 16 meg level 3 cache. Now there are all 8 cores talking to each other. So they're seeing the entire L3 cache unified. There are 32 megs to enjoy, and what we can do with some SKUs is actually disabling most of cores to ensure that these cores, the remaining ones that are active, do have a larger level 3 cache access. So this speeds up certain applications ranging from, for example, databases and HPC over to, for instance, virtualization, which is not an application, but still an environment. We can add virtual machines in a more efficient way. And by the way, before I forget about this, VMware has announced that their vSphere 7 update 2 actually brings up to 30% better performance for Rome. So it's just an update, and you finally are able to enjoy all the micro architectural advantages of our EPYC processes. It is what happens when you start to look into how to better optimize for our scheduler, for our cache subsystem. That is the direct benefit for those who already has deployed our service, Zustec service based on EPYC processes. So if you look in general, there are not so many changes. It's still the same kind of I/O and memory subsystem. It's still the same thermal power. It's the same core count. However, the changes are under the hood, and they are very important. One of the largest subjects that we always address now during the pandemic is our security subsystem. We have a very strong vision in terms of how data in use has to be encrypted. It's actually basically was brought to x86 market by us, because if you look at how holistic the entire thing is, it's quite amazing. And we see the industry, both cloud providers like Google, like Azure, like IBM Cloud, they're all following this route. If you look at what is really brought to the market ever since our first generation Naples processor, it's an ARM security processor, AMD secure processor, we call it this way, that has its own table to store keys, 128-bit strong encryption keys. First generation just had 16. The second was updated to store up to 509. And so the second generation, what it was able to do compared to the first one, it was not only securing DIMMs, so you can actually just issue one key. It's unique. It's contained inside the CPU. So all DIMMs are encrypted. and there is no performance drop. You just enable it in BIOS, and this is good for example, for edge deployments when you have uncontrolled servers. I don't know, for video surveillance, for instance. What we've done with the second generation is it's not only this physical memory protection, and not only our encrypted VMs up to 16. It became upgraded to have 509 keys, so you could use more than 500 keys to isolate cryptographically all VMs that are running, but still there were a few ways to actually penetrate into hypervisor. The second generation processor was really addressing with SCVES encrypted state, addressing the security of CPU registers compared to the first generation, and obviously the number of VMs was larger. The third generation, what we're now doing is we're really looking at into prohibiting, administrators, or let's say the hypervisor itself, from reading into context, into memory of virtual machines. So there are ways to make sure that the copy of memory space is not rolled back. For instance, if it's compromised, we really just close on this vector of attack. And if you look overall how many security bulletins we issue, it's really impressive to see how it pays off to have security reviews, in parallel to microarchitecture designs. This practice was ever since 2014 when we, envisioned the entire EPYC family. So we really worked very closely in terms of how to make sure that our security stack does not really affect the performance. If you enable encryption for virtual machines, what we've seen is pretty much 2 to 3% performance gains. And the best thing about it is that you just need a hypervisor aware of our technology and an OS, and your applications stay the same. You do not need to recompile them. The entire memory space is protected. It's really amazing what we were able to achieve, and we see now that it's both public clouds as well as private setting, right? Private clouds. And so, for example, VMware vSphere 7 does support it. KVM-based Linuxes do support it as well. And so, let's talk about the range specifically. Milan is about 16 or 18 SKUs in total. It's both single socket and dual socket. The single socket ones are more aggressively priced. We want people to migrate to single socket compute. And so they have letter P at the end. What's interesting about it is that we're not trying to, we will make sure that Rome coexists alongside with EPYC. We see a great value in Rome. It was designed to compete with Ice Lake, and so Milan is a thing on its own. It's very competitive already with the second generation. We just add where it makes most sense. So what you see is a pretty dynamic range from 8 cores to 64 cores, and whenever you buy an ASUS server with EPYC CPUs inside, remember this: whether you pay for the lowest end or for the highest end, you always have the same kind of feature set. We do not fuse it to really move you up the stack. If you need a software-defined server, for example, you don't need to buy, and you need a lot of PCIe lanes. You don't need to buy a higher priced processor. You already have it with 8 cores. What's important is that we don't introduce any kind of low-end 8-core processors with Milan. You would need to buy Rome. There are 4 high-frequency, large cache parts that are application optimized. But also you see some interesting core counts, like 28 cores, like 56 cores. So what we are now doing is, for people standardized on these core counts, we introduce aggressively priced Milan parts that provide great value and good performance to compete versus competitive Xeon built parts 6000 series. So with that, let's move forward and talk about how the performance is. Already, our second generation was already so capable that we were quickly taking HPC market by a storm. If you look at our history, we started out really with working with MDCs, mega data centers, cloud providers. These were the teams actually that recognized the potential of EPYC. And it was not until second generation Rome processors when we actually were able to start to start winning deals in HPC. And in fact, if you look at our progress last year and you compare top 500 HPC installations, June revision versus November revision, we ended up growing almost twofold to I think 24 installations based on EPYC. It's a very big progress, and there are 2 out of 3 exascale machines being built on AMD. The largest European machine was recently announced. There is a deal in Australia called POSE, again, the largest supercomputer. So it's a great story. But for me personally, all my eyes are set on enterprise, because we're now seeing new customers of different size, normally larger customers, larger enterprises, coming to us and asking to brief them, because they definitely see that the compute power is better, the compute density is unsurpassed. It's a very scalable platform. There is a very stable roadmap. The security features are second to none. So we see a lot of enterprises coming our way today. And they are talking about, not only just specific niches or pockets of applications where they see us. No, it's pretty much 100%. So first off, HPC, let me put it this way, it's more than 2 times the performance if we are taking our highest end 64-core SKU at 280 watts. But it's still substantial if you run, lower power processes. It's very efficient to work, to make sure that, either you have faster time to result, or you have, larger data sets when you run your parallel clusters. In terms of the integer performance, and let's look at cloud, definitely, again, the same kind of thing. Our 9 out of 10 mega data centers, cloud providers today use our infrastructure. We're going to enjoy probably up to 400 instances in bare metal offerings this year. A twofold increase from where we were a year ago. And so what cloud providers love about EPYC platform is that the density is so high. They're really targeting 2 socket systems, and they put as many cores as possible and distribute their workloads. It's amazing what we're able to do here. And enterprise, again, if you look at 2-socket Java virtual machine performance, looking at spec JBP, again, a substantial performance gain on that front as well. But it's not only, the top end 64-core SKUs. We see the most benefit with Milan in the mid-ends, because that's where you will see the performance jump. The mid-end SKUs, ranging from anywhere from 16 to say 32 cores, you'll see up to 25% performance gain if we're looking at spec integer. Or more, actually. Some OEMs already started posting their results, and we see even better than that. If you look at the 48 to 64 core SKUs, especially 64 core SKUs, that's a different story, because you need a lot of power to drive cores to stay at the highest clock speed, boost clock speed. So we're getting there probably up to 15% performance if we're looking again at spec. And our high frequency SKUs compared to the previous generation high frequency SKUs, well, about 23%. That's what we quote. And so with that, let me wrap up by saying that, look, if we validated EPYC as a platform, its viability with first generation, people were surprised and took notice with our second generation, started to massively deploy it in cloud space, in HPC, and for HCI and virtualization for example, in enterprise. What we see with Milan is it's amazing. We already have a lot of customers lining up because they see it as their next choice. It's a stable infrastructure. We have a very solid roadmap. It's the fastest CPU both per thread and in terms of compute density, it's unsurpassed. And so at the end of the day, it's not only that, but we provide a better security stack in the sense of isolating virtual machines. This is a unique feature to AMD. We can isolate, we can encrypt memory, physical memory, DIMMs, and so we can even, work on secure boot. So our processors have unique identifier, and they can actually validate the way actually the entire ASUS server is booting up. So it's really amazing because these are the pillars of today's interest for many customers. And with that, let me thank you and pass it to Daniele. Thank you.
Hello, thank you for Alexei for the presentations. Next, we have Daniele to share his ASUS perspective on the EPYC server and the solutions. Welcome, Daniele.
Okay, thank you very much, Irene. Thank you, Alexei, for your presentation, and welcome everyone from my side. My name is Daniele, and I am the Server Business Director for Western Europe. And I have to say, at ASUS, we are very excited about this new AMD Milan platform that Alexei introduced. And for this reason, we have designed several brand new server systems to provide you with the hardware to enhance the performance. And moreover, on personal base, I couldn't be more enthusiastic about introducing a product line that is named after my city and my football team. So with Milan as a name, you already know it's a great product. So talking about my presentation, we can address and sort the ASUS lineup by different workload to have a quick overview about which product for which user scenario. So here we split into 5 according to the winning factor of each preset. We have the hosting, and RS620SA is our 2-use 6-node solution that is 50% more density compared to market standard for EPYC processor. And in each node, we can host a Milan CPU up to 280 watt, 8 DIMMs, 2 M2OS drives, and even 1 low-profile GPU. Moreover, the base unit also accommodates additional 2 hot swap drives per node for a total of 12 front bays. So you have here density, computing power, storage capacity, you name it, RS620SA has got it all. We have virtualization and cloud with RS720A and RS700A, which are dual processor with 2U or 1U form factor. It comes with 32 DIMMs, up to 24 hot swap storage bays, and even up to 4 double-deck GPU cards. And for a more mainstream solution, if you don't need to add GPU computing, RS500A is a 1U single processor, 60 DIMMs, and 12 front bays. We have analytics, data analytics, and thanks to the computing capacity of the new Milan CPU, RS720A and RS700A, dual processor with 32 DIMMs and a large storage capacity, can actually process a previously unmatched amount of data at a previously, I would say, unmatched speed. So if you maybe wonder what all this computing capacity or storage capacity could be for, we should think, for instance, about machine-generated content or streaming, video analysis, video management system in real time for smart cities, retail, surveillance needs, industrial, research, simulation purposes, and so many more. So actually, we are starting to acknowledge that there is no limit to the increasing compute needed in the current modern area. Machine learning, training and inference optimized for GPU acceleration. Machine learning is actually also one of the frontier of the current modern challenge. We have here ESC4000A, which is a 2U single processor that can host 4 double-deck GPU, or even it can host 8 single-deck GPU thanks to its flexible design that we will see a little more in deep in the following slides. And ESC 8000A is a 4U dual processor that can accommodate 8 or actually up to 10 dual deck GPUs, and all of this would run at per 16 speed with the new PCIe 4 generation standard. So providing solution to host the largest possible number of GPU with the highest speed of PCIe 4.4 into the smallest possible space is the ASUS commitment to GPU computing solutions. And last, we have software-defined storage with RS720A, RS700A, and RS500A. All the drives could be NVMe. So this provides with the highest possible speed to design and run your perfect storage solution. Coming to the next slide, we spoke so far about some spec, but let's see how the product does work. And we can see that ASUS won 712 world records for speed and power efficiency from spec.org benchmark website. So among all of these 720, we wish to highlight the world's fastest performance that was awarded on Milan CPU for RS720A. And of course, the best power efficiency, which is intended as computing capacity per watt, that was awarded to RS620SA and RS500A, both under Windows Server and Linux environments. Now let's have a quick recap of the ASUS proposition before we get lost. So please keep your eyes on this slide and don't blink. We know from Marvel Studio Universe that blink can be very dangerous. So we have on the left balanced single processor 2U 24 bays or 1U 12 bays with RS520A and RS500. We have performance dual processor 2U 1U design for RS720A and RS700, and the 2U 6-node density champion RS620SA. And last, on the very right, we have 2 GPU server offering 2U and 4U, ESC 4000A, ESC 8000A. So we are talking here about a new generation, new product. And we should say new generation is always a very good excuse to introduce new design and new feature. So in particular, among all of these you can see here, I would mention some. And to my knowledge, ASUS is the first and so far the only to adopt the new AST2600 BMC controller. So this controller is equipped with a dual-core processor and double dedicated DDR memory and SDRAM size if we compare it to the previous generation AST controllers. It has 4 times the baud rate and a very long list of improved spec that I will not go through because I can't even spell them. But in short, what is important, what it does is, it cuts down by half the boot time of the machine, and it allows 4 times more requests using half of the previously needed CPU processing power. So enabling this a much faster web time response, and also, it goes without saying, the security functions were widely improved compared to the previous generation. Some other feature that deserve mention here, of course, the water cooling ready design, and definitely the increased density of GPU and FPGA, together with OCP 3.0 for fastest networking and PCIe 4.0 bus, that this was actually already available in the previous AMD generation and ASUS server for AMD. So now let's have a look a little bit closer to some specific model like RS720A E11 here. As we said, it can host 24 2.5 inches drive. It's a 2U dual processor server with 32 DIMMs, and it has a modular design that allows us to configure it with 1 gigabit networking or 2 per 10 gigabit networking. Or if you need more, you have OCP 3.0 interface to connect even faster solution. And on top of that, in this very chassis, we can also fit 4 GPU or FPGA cards. We have RS700 and 500A, which are similar to the previous model, but these are in 1U chassis. RS700A can host one dual GPU or FPGA card, and RS500A is the 1U for single processor, so it's a mainstream solution, but we like to add something particular on top of everything we do. So the advantage of this particular solution is that you can host up to 16 NVMe drives. Now we talk again, but just for one single slide, I promise, about the 2U6N ASUS unique design, which is improving by 50% the market density standard for the AMD EPYC server multi-node solutions. And in this 2U unit, per node, we can fit one CPU, one GPU, PCI Express expansion slot, OCP 3.0, 8 DIMMs, 2 and 2 OS drives, and even 2 NVMe front bays. So just to make an easy, simple calculation, if we think about a standard rack cabinet, which is 42U, we could imagine to fit 21 units of this server for a total of 126 nodes per single rack, compared to an average of 84 nodes capacity from our competitors. And this means a lot in terms of density, space, and cost, and also power saving, which is probably leading the infrastructure to the possible ever lowest cost per node. We have here the ESC4000A, which is actually the first ASUS product NVIDIA certified system. It features a butterfly design, so you can host on the back, on the two sides, 2 dual deck GPUs per side. And you can also have it with 8 single deck GPU by adding an accessory PLX PCI switch board to it. And definitely in a 2U with 8 GPU cards, that is probably the highest density as well. Now, slide, this is also a small recap. So to compare with the previous generation, with the current one, I made a list of the hardware and the software management tools that have been improved. So for instance, we have now hot swap fans, cable routing, and ball bearing rail kits. And on the GPU and FPGA side, we can now host up to 4 double-deck GPUs in the 2U dual processor 24-bay chassis of RS720A. We can have 2 in the 1P, one single processor 24 bays of RS720A, and 1 in the 1U RS700A dual processor. Comes to my mind that I did mention so far quite many times the word FPGA. So what is FPGA? FPGA is actually a programmable or accelerator card that can run specific and customized programmable functions. So it is somehow similar to a GPU, and but it can be programmed on purpose to do a specific task. The Alveo Xening series is certified with ASUS server and can support, for instance, machine learning or distribution of video workloads, being, let's say, dedicated and programmed on purpose for running at the highest speed this specific task, and with the given advantage of being passive cooled and consuming just around 75 watts, which is a very strong saving if you compare to the generic GPU computing requirements. So, as I said, the ASUS server are certified with Xenix accelerator cards. ASUS AMD platform is also certified with independent software vendors for different kind of workloads, like virtualization with the VMware, or Ubuntu, or Sangfor, and hyperconverged infrastructure like Azure Stack HCI. So this means that it will be totally trouble-free deployment with the ASUS server under this application and these infrastructures because the environment is certified and granted. Now talking about the Azure Stack ACI and the software predefined structure, from the hardware point of view, what is needed is to provide flexibility in terms of storage capacity, networking, and GPU support. And that is why at ASUS we put so much effort increasing the hard drive base, the networking modular design, OCP 3.0 support, and of course GPU and FPGA density. So together with Milan series, ASUS server can operate at the highest number of virtual machines with the topmost performance, efficiency, and, as Alexei also underlined, the highest data protection security level. Don't worry, we made it to the last slide, so I need you to survive a couple of minutes longer. And luckily, there's an open bar at the end of the speech, but unfortunately, we are not able to join it because we are all in lockdown. So here you can see the preset for the different Azure Stack ACI structures. So for branch office and edge, we have RS500A, 2 to 16 nodes, single processor, 12 SAS drives. For SQL server preset, RS700A E9, dual processor, 12 SATA or SAS drive. For virtualization, RS700A E11, 2 to 16 nodes, dual processor with 12 NVMe SSD drive. And for scale-out storage, RS720A E11, 2 to 16 nodes, dual processor, 24 NVMe SSD drives. So that is all from my side. I thank you very much for the attention. I'm looking forward for your question, and I hereby return the control to Irene.
Thank you, Daniele. I think no one will doubt you are the best person to introduce Milan ASUS server than anyone else. This is the end of today's webinars. I hope you have learned much more about our new server based on the AMD EPYC 7003 processors. And please thank you again to join today's webinar. If you are interested in our presentation deck or video, or you have more questions about ASUS server, you can always contact with our ASUS local representative, or you can contact us directly for the questions. And we look forward to see you very soon. Thank you for today. And
thank you all.
Have a good day.
Very much. Thank you, Alexei. And
thank you
to all
thank
the
you.
attendees.
Bye-bye.
Thank you very much, everyone.
Keep safe.
Thank you. Bye.
Bye-bye.